welcome to the fourth and last video on polymorphism and inheritance. On this video, I want to start looking at the actual mechanism a little bit more deeper of how the compiler and how the compiler decides what method to call. I talked about it. It's basically an extension of the two compile time and runtime scenarios that I talked about before. That still stays the same. What I did here is I made some small changes to the code. I changed the current date, nothing big. I'm not even going to use this. Let's get rid of that comment there. But I did start exercising this method that I sort of have been ignoring in the last 3 videos. And I'm going to I commented out all that other code too. It's still good code. I don't want to get deleted. So if you want to go in there and try this code out, you can uncomment this, so it's there. But basically, this is what I've got. I've got this pets_of_i.method, and I just made up new bird. Okay, what does the system do? There's apparently no error here, but what does it do when it encounters a situation like this? Well, at compile time, what the system will do is it says, is there a method called method that's defined for pets of I? Let's go down here. Yes, there is. There's a method defined inside pets, and it doesn't say it takes just big birds. It just says it takes a generic pet. See, what the system does is it says new big bird. If it doesn't find exactly, notice I hid this out. I commented this out. If it doesn't find exactly the type that that the parameter has, it will look. It tries to find the next best thing and say, well, a bird is a pet. So it does find this method here. So at compile time, it will allow you to make that change, or it'll actually allow you to write that code. At runtime, the system says, okay, all right, look at the actual object that we have here. Is there certainly what the system is going to try to do is try to find a method that at compile time matched the pet parameter. Is there a method that takes pets defined for the actual object that's in here? Now, when I run this code, okay, and whoa, look at this. 90% of the time it runs pet.pet, but then all of a sudden bigbird.pet method got executed. Why is that? The thing is this. Okay, 90% of the time, there's only 10% of the time you're creating big birds. I think you're creating big birds, and so big birds have its own definition, overrides the definition of method that takes pets. See, at compile time, the compiler is looking for, okay, this might be a bird, but it's going to match method that takes pets because that's what I've got defined here. Now, all the other classes don't even do anything with methods other than, then there's bird that takes objects, but Big Bird does go out of its way to redefine the method pet. Well, at runtime, it finds this method that takes a pet and it prints this out. Any other object that's not a big bird, okay, doesn't have a method that takes a pet. This might take an object, but doesn't take a method pet. And that's why you're going to inherit, these classes inherit this particular method here, and that's why most of the time you see pet.pet method. Now, what do you think is going to happen if I say, well, let's come up here. Instead of creating birds, I create a cat. You think it'll make a difference? I don't think it'll make a difference. See? Pretty much the same thing. A cat is a pet. At runtime, it's going to look for a method that takes a pet. Does the actual object have a class that's named a method that takes a pet? No. Other than here, this guy redefined it, and that's why I print this out. Now let's make it interesting. Let me put this thing back in there. Put this right back in here. And now we've got two different methods that are overloaded. One that takes birds and one that takes pets. Okay, let me call this pet. Let's be consistent. This is going to be bird method. Bird method. Let me make it consistent. All right, let's see. And let me just take a look at that one. Bird method, bird method. Okay, it's going to look fine. What do you think is going to happen here? All right. Well, right now I'm creating a cat. A cat is, remember, here's the hierarchy. Let me show you the hierarchy. Here's the hierarchy. A cat is a pet. It has nothing to do with birds. Okay. So as far as we're concerned, I don't have any special method that takes cats. So the system's going to try to match this pet method. It's going to try to look at the actual method that takes a pet. If the class has that defined, big birds have that defined, and you're going to see it didn't really make much of a difference. We get the same here. In this case, we had a couple of big birds. Okay, now what happens if I create a bird now? Let's do, where's my bird go? Let's go ahead and create a big bird. Big bird as a parameter. I'll spell it right. Big bird as a parameter. Now, what is this compiler going to do? Okay, it's going to say a compile time. Is it okay for me to take a method that takes a big bird? Well, I don't see a big bird, but I see a bird. So forget this guy. If you passed it a bird or a big bird, it's going to try to locate this method. At runtime, it's going to go ahead and look at the actual object to see if it takes a bird method. A method that takes a parameter of type bird. Let's see. It does right here. It's going to call big bird method. Okay, so what does this mean? This means that if the object is actually a real bird, big bird, okay, it's going to execute this method here, not this pet method. You're never going to see that. If it's any other object that you pass here, any other object, let's say a cat is a pet, and it's going to look for this method, okay, and at runtime it'll find it only in the big birds. So if I run this big bird method, yeah, because it was at compile time it established the method that you're looking for is a method that takes a bird. I passed it a big bird, which is this, it matches that. That's why we match this. If you don't find it, if big bird, if you don't redefine it, like all these other things here, we didn't redefine it. And so big bird, okay, let's see. If we were actually dealing with a dog, okay, if Pets of I was a dog, I didn't redefine the bird method there, so it's going to locate. I didn't define the bird method, so this is the method that all these other classes will use, and say pet.bird method. That's the one that's going to run. But if the actual object was a big bird, okay, which in this case we have a big bird apparently, because the bird method that we redefined that bird method because there's the actual object there. All right. We're done with the polymorphism. You have to really wrap your... I'm going to give you the code for this. Play with it. Wrap your mind around it, because this is code that you're going to need to understand, because every object-oriented language has this mechanism that I've described, whether you do Python or C++ or JavaScript and all that. And all that works the same way. And so you need to wrap your mind around this. It's not just a Java thing. It's a programming thing. All right. We will see you in the next video.